Yeah. So my name is Jamie Rahman, and I'm talking about logistic regression. So logistic regression is used to solve binary problem. If you say the equation itself says it's a logistic or it's a logistic curve, which is in the form developed using linear regressions. It's a derivative of linear regressions. And let's just talk about some programming features, what we can do it, and what are the data explorations required when we work with logistic regression. First thing is we always should import pandas package, and as we are going to use logistic regression, make sure that you import that package. So here we are discussing about the Titanic dataset, and if you look at it, if you put if you load the CSV file that contains the dataset, and you look at these columns are indicating that these are the features, and each feature represents something that may require in the analysis or not. So we should come across what is the features. So if you look at these, survive is the features we are going to calculate. It's yes or no survivability and the Titanic. That is our prediction should have. So this is the predicted level. It should have the yes or no and other all our features that we want to see how it's going to impact our prediction. So first of all, this bar chart what is doing a box plot that is developed using the Seaborn package library, and this SB is the object. So if you run this command in the histogram plot and from the Titanic dataset and with the column survive, so we can see there are two different types, 0 and 1, that indicates it's a binary problem. So we can have either 0 didn't survive in the accident or one survived in the accident. So then next let's discuss what other things like we can do. When you work on dataset, it's always advised to see if there is null values in any features. Running through these datasets, pandas data frame is null sum indicates each column or features that have either null values or not. So we can see age is the column which have 177 features that are missing. Similarly, Kevin has 687 features missing and Emberg 2. So out of 891 entries or records, so we have more than 50% Kevin records missing. So the rule of thumb says when we have more than 50% records missing, we can ignore that particular features or columns. So we are good to delete this one. But what about age and embark? So this is the first thing of and data explorations. Filling up any missing values, remove where you cannot help removing, correct? So out of cabinets almost all missing values. So we are ignoring, we are deleting this. And again we are going to delete drop passenger id because id has nothing to do with analysis. Similarly name, if we indicate the name and wanted to predict something, it will be more like a bias. We will be more biased on something, right? So we are going to delete it. Ticket, when ticket number has nothing to do with analysis. And the cabin itself, which cabin the person seat has nothing to do, so we are deleting this. After removing, after drop method is dropping these features, indicate that's one in the y-axis. So in the all the vertically if you delete the passenger id or the passenger id remove, name remove, and ticket and cabin remove. So these are the, now if you put the head method, it will print only the first five records of all the features present. So we have removed these four features just as of now. And after that, next thing is we have missing values in the age we know. So how to replace it with some appropriate value. So this is a box plot which indicates the average age of three different class of people. First class, the person sitting in the first class of the sheep, second class and the third class are of age like this. And average age is 38 years, 28 years, or 26 years like this. So now if you have a data like this, we can easily put in a formula where putting the age, if it's a first class, we return 37 age. If the person is sitting on the second class, we can return. So how we get it? See, if a person is sitting in the first class, class is third class, we can return the appropriate age, right? So if it is a missing age, we can put the average. If it is a first class, if it is missing, we can put the averages. So how, if you put this kind of data, box plot of average and passenger class, we can get into a formula if it is a P class, first class, and the average is the second class, the averages of it, and third class, it's 24. So we have replaced this with the apply. Apply is a method in the pandas data frame using which you can apply a method. It's a method, it is approximate, and we are supplying these data frames with age and p class. And if the p class is of type something in the records, what is the age should be returned. So that, well, that's all it's doing. And doing so, it is replacing all the age records that are missing. So we, when you say tightening data is null and some, next time we cannot see anything missing here, right? So what next? What next? We come out across something when we do not have anything apart from Ember. There's only two data are missing, so we can directly do the drop now as we have modified our data for age and for the other records that's missing. We already did our best calculations, like we've removed most of the missing data that's are of type cabin, and average is for the age records, series cabin and average age. Now only we are left with Ember only two records, so we deleted that in the last time. So now we are good to go. If we say again tightening data is null sum, we see there is no missing values. So what next? Now we can create into something, see, logistic regressions. In any data analysis, the data should have be valid. We did it that. The next thing we should work on the categorical variables. If something has like not numerical, we cannot calculate and machine cannot calculate, right? So we have to convert it to equivalent numerical values. That can be done with hot encoding, and there are several methods to do it. Get dummies, what is doing is plotting one for all the male and zeros for all the missing values. So doing this has some advantage, like we can now convert like embed location also, which has categorical variables, and convert it into the equivalent numericals. And doing so, we can change the data frame with by dropping these two sets and embark with equivalent that we have done it just above, just like using the concave using a new columns along the axis one. So to see, and if you see that now we have equivalent numericals for the column 6 and embark locations. So now the next thing is in the logistic regressions, the data should, the features should be independent of each other. That we can validate using a plot like a heat map, which is correlations between two features. And doing so, we get into something we can find out if these features are correlated. If it's a highly correlated, positively correlated, we have to delete this. So we found that fair and p class are not independent of each other. So we are going to drop it. So the next thing is we are once we're done with all these things and we are ready to go. We do not have something like we know that we have to predict our first thing is the column survive is the prediction thing and all are the features which we have to work on it. So then our main thing is to understand how to trace and split the data. Remember the machine learning, the next thing is to split the data between test and training set and do on. There is the fundamentals of what is the division of the test and training. I want to explain this using a different tutorial. Thank you for your time.